Hello everybody, welcome to my lab number 4. Today I'm going to be doing a lot of frequency stuff with this. I've got an N-scope right here. It's hooked up to my Arduino, and I've got some virtual spectrum analyzer running through my Arduino. So it's pretty interesting stuff, and it all runs off of this right here. This Arduino code right here. So you start off with the serial.begin, you've got your pin modes, and then, I've taken the sample frequency, and then I use that to calculate I've taken a variable called sample frequency. I do some calculations with turning it into a float it's not a cast, it's a function, but hopefully that gives you a good chance to see it. I don't actually take in A1 as a variable. I just directly print it. So that's one way I think I made my code a little bit efficient. I also went with the standard delay as opposed to any of the other ones, just because that was easiest to implement, I think. But let's get into my actual code. So here is all of my stuff, all my pictures. Each page is one sample frequency, and it's all in the same order of top to bottom, like that. So there's that. And there's some pretty interesting things that I saw when I was going through this. For example, let's go to the top frequencies. So the 500 hertz frequencies are all pretty good, but the 100 hertz frequencies are pretty aliased. So it's actually really interesting to see how the aliasing can actually work when you change the sample rates. I thought that was pretty cool. For example, this plot right here, you can see aliasing in that. Let's see. You can see some aliasing here with 2 frequencies. This one is pretty aliased as well, down to 6 frequencies, or 6 hertz. Let's see, so this one was really interesting. The sine wave looks almost as if it's a 1 hertz sine wave, even though in reality it's a 215 hertz signal. So I thought that was really interesting. Here is my table where I have all of my stuff, all my numbers. Get a chance to see this. Now obviously in some of the 500 hertz sampling, there isn't really much aliasing, whereas there is for the lower sampling rates. I used this, if it will actually focus. I did some calculating to get the sample frequency. I got the the Nyquist criteria of the Nyquist frequency being greater than the Nyquist rates. Yeah, and before I run out of time here, let me show you some triangle waves. Check that out. Pretty cool, huh? It's got a really interesting spectrum analyzer thing right here. As you can see, it's got, since it's a 10 hertz signal, it's got, the big 10 hertz signal, and also I think there should be one for 20, but it's probably being covered up by the noise. But you can see it's much smaller past the 10 hertz. Whereas if I go to a pulse wave, then here you can see, look at that, it's a pulse wave and it's increments of 10. So yeah, just barely 5 minutes. There you go.